DigitalOcean hosts every year. I think they've been doing it for like the past 10 years now. But basically, what it is you find repositories that have this Hacktoberfest tag. Let me see if there's like a little thing down here that tells you. But they have this Hacktoberfest tag, and you put pull requests on it. And basically, what you do is if you get a certain amount of pull requests, I think it's five. If you get five pull requests, you can get like this free shirt. And that's also something you can talk about in your resume. Be like, hey, I participate in competitions and stuff and events. So yeah. Any questions about like Hacktoberfest that you guys are?
It does help get some stuff on your GitHub too, so you actually have some pull requests going out instead of just personal projects that you have, such as schoolwork. So, and just looking through some of the stuff that other people do, it can help you learn some things. So like there was this one I did, I think last year, where it was just all the different data structures you could do with a bunch of different languages. That one was pretty interesting to look at to see how people optimized it.
Mm-hmm. Yeah, and this event runs from October 1st to October 31st, and they do have maintainers of this event that checks like pull requests. So like obviously, if you just do like you just edit like one, you just fix one grammar thing on the README, and that's all your pull requests. They're gonna check that and be like, yeah, no, this doesn't qualify. You have to have valid pull requests where you're actually contributing code and stuff. So, yeah.
Cool. Yeah. And if you don't like the ugly shirt that they're giving away this year, you can also plant a tree, which I think is pretty dope.
This is the two colors. You have this one and you have
Okay,
this one.
that's a lot better. The blue is a way better. Like I said, make it navy.
Okay, I like that color way better than the other one, like Drew said.
Unless it's just some like dark mode gimmick. Like that better be a real shirt. But then again, the pink would clash with my hair. I'm planting a tree.
Anyway, yeah, so we'll talk a little bit about Git for those of you that have never done it before.
If I may throw something out there.
Yes, please do, Drew.
Jacob, Wesley, and Robert, would you like to hear about Git? And if so, do you have any specific questions about it? Because there's only 3 of them, and there's 6 of us.
That's fair, yeah.
It's 2 to 1. Rather than give a lecture that's designed for multiple people, why not just address some of the particular questions they might have about it if they're using it in any classes?
I've never used it. It's something that I've been introduced to recently, and I don't know that I have any questions about it, given that I know so little.
Maybe then, Drew, do you just want to show some basic stuff with Git and how to use it? I think that might be effective. We can't hear you. You are muted.
Sorry, I apologize. Let me share my screen. Cool stuff. Okay, so Git is something called version management, which essentially just manage which version of the software, or really it can be used for any folder in your computer. So it's managing which version you're on. So rather than saving, and then if you want to go back, holding down Control-Z until you go back to the state or the paragraph or whatever you wanted, with Git, you can just jump back to it. So
question for everyone. If you've used Google Docs before, it's kind of like Google Docs for programming and files. Same idea where you have a history and you have like, you can have multiple collaborators on things.
Okay.
It does not autosave though. It will not autosave every single code.
It's not Google Docs in terms of UI. It's Google Docs in terms of we can save things and other people can edit.
It's exceptionally useful.
Okay. So here we go. I am on my desktop. I'm making a Git folder called Get It because we're about to get it. That was terrible. I apologize. Okay, so CD for Get It.
I want to end my life.
That don't know. Can everybody see my command line?
Mm-hmm.
Yeah.
Okay. Yep. I'm also going to keep it open right here because I think it's nice to have some of the rules on what's going on. So Git init for initialize is what you're going to do. And it actually creates a Git folder. And if you're on Mac, Command-Shift- will show the hidden folders. So you can see that it's right there. You can also do list and then Alt for all of them. That's typically just what I do to put them in the list form. And we have it right there. And that file wasn't originally there before. So that means Git has been set up in this directory. So let's create a file. I'll do like touch. In fact, I'm just going to open this guy really quickly, and I'm going to do a quick Ruby script. Hello. No, not hello world. I do hello there. And I'm going to save this in my desktop and get it. Save, save. Okay, cool. So right there, I have untitled.ruby, which is hello there. And I'm able to run this and it spits out hello there. So pretty straightforward. And I'm keeping this up and I'm keeping this up because I want you guys to see what Git does exactly. So let's say I want to make some changes to this, right? And I need to add some code that replies to something. So I'm going to create a new branch, which is git branch. And you typically do like git, then the branch, then the name. But a really safe way to do that was actually showed to me by Chris Keefe. And this is kind of the official way to create a branch for stuff that happens behind the scenes. Git checkout branch, and then like dev1. Okay, so I actually have shortcuts saved. So git checkout B, I have a folder with a bunch of aliases. So instead of typing out branch fully, I can just do B. So what checkout does is essentially is you have a pointer pointing to your master branch, which is kind of the main thread that goes through the entire program. And git checkout creates a new branch to start editing off of master. And that way, any changes you make inside of what I'm calling dev1 are not related to master. So just to confirm that I'm on it, one thing I can do, if you have a Mac, I recommend getting iTerm, and you can actually just have it show your git status up there. Otherwise, you can do git status.
Hey Drew, could
yeah.
you please explain what master is?
I just did. In more depth.
Mm-hmm. Like
Okay.
how is this different from, how is master different from dev1?
I thought I just explained that. Sorry, was it not clear?
No.
Okay. So what are you confused about? I said it's a different environment. I'm pretty tired today and having a hard time.
Well, I'm mostly asking for the new kids because this you're kind of going pretty fast. That's all.
Oh, okay, cool.
It seems like it's just
Okay, so let me do something, and then I'll explain what I did, and I think it will show the difference between master and dev1. Okay. So everything with Git starts on master. In Git, you use something called branches because they're all branching off each other and it ends up looking like a tree. And master is the main branch. Think of it as the trunk of the tree. And the reason it's significant is because in most cases, you only want to put the good stuff on master. So if you are working on code and your buddy is working on code and you're working on it for a project, you know, your super cool app, you're creating this app, you want to make sure you can develop your code without messing up the app. So how do you do that? Well, you keep the app on master and then you create a new branch based on master, and it has all that same code, but now it's headed off in a completely different direction. So you can work on this branch in this entirely different environment without really messing anything up. Is that a better
explanation? So it treats master kind of like a template with like wherein you can place maybe something unstable or something that you haven't really confirmed is going to be inside of the master yet. Maybe yep. Like, yeah, it's the kind of thing that you would do like in an industrial setting, maybe with like, I'm trying to figure out how to explain it. I understand it. It makes sense.
So let me give you a real world example. I can't show you the code because it's for a class and it's something that people might want to copy. But we're developing a ray tracer in 430, and that's a very complex project that Colton is working on, I'm working on, and a couple other people in ACM are working on as well. So the project is cumulative, kind of like one that you'll have for operating systems when you eventually reach that class. I'm sure you've heard about the simulation and horror stories and such. It's not as bad as it actually seems, just stay on top of it. But what it allows you to do in our case, or so what it allows our team to do, is we have this working code that we just submitted. We got full credit on it or whatever, an A, and now we have to add more to it. How do we add to it without breaking it? We can do that in a new branch. So what I just did that I wanted to show you, so if I do git br, oh, Kanoa's here. So if I do git br or git branch, it shows me my branches. And right now I'm on master, and then there's dev1, okay? So if I'm on master and I open this file, I have hello there, and then I have hello there as well, right? So this just prints hello there and prints hello there as well. I could have done the same thing for Microsoft Word. I'm doing Ruby just cause. Let's say I need to make some changes to this file though. So this file is working perfectly. What I'm going to do is check out another branch. So do you remember when I created dev1? The commands, I would say focus more on the principles because the commands kind of can go over your head at first. Kind of like with syntax. Syntax changes per language, but what really matters as a computer scientist is that you understand the principles behind it. So I have this, silly little program right now that's just like printing out a conversation, and I go, well, let's say I want to add to the conversation. So I'm going to do that in my first development environment, dev1. Now, it might make more sense to do that in a name that's like a good variable, not just single lettered, but kind of descriptive. So maybe I'll do like git checkout, create a new branch, conversation. And the reason checkout is nice is it creates a new branch and moves you to it. So if I do git br again, it has a little asterisk next to conversation. And in this folder, which is my git it folder, we can start to modify this code, or we can create a new code. So git status, it says nothing to commit, working tree clean. So remember how I talked about the idea of git being a tree? It's clean. All the fruit on the tree is happy. And now we're about to make it angry. So I click on this code, puts hello there, puts hello there as well. What? Okay. Hello there for a third time. And obviously this isn't how you talk, but somebody decided to code it anyways, right? And now if I do git status, it says modified, untitled Ruby. So that tells me that there has been a change since my last commit. And that idea, oh boy.
Oh, everybody get ready. Dr. D's here.
Yeah. Okay, my boss and the
ACM
sponsor just
advisor.
joined. Hello, Dr. Dory.
Hey guys.
It's Dr. Dory. Hey. Oh, no way.
Howdy.
I have to explain Git in front of my boss. So this change, think of Git in relative terms. Obviously, I changed the code, but I've changed it since when? I've changed it since the last commit. Since we are on a new branch, I have changed it since I created the branch. So the question is, do we want this code or do we not? Let's say we want this code. You're going to add it. And this is where Git can get kind of confusing. I'm doing git add dot, which actually adds all. So with Git, you have two areas until it's back in master. You have something called a staging area that you add your code to, and then from there, you commit it. And then after it's committed, you have to pull it into the main branch. And it can be a little bit overwhelming at first. But think of this as just a regular change. And then if I do git status again, it says it has been staged. So git add puts it in the staging area. And that's kind of, rather than just hitting save, think of that as like a pre-save. So I think I want this file, but you know what? I actually don't. I want to make a small change and add this exclamation mark and save it. Well, now it's actually back in the regular area, and it's also in the staged area. And specifically this change, the exclamation mark has been added. So what's nice is it shows you, hey, this is the last commit, or sorry, not commit. This was the last add that I was very sure about. I felt very good about my code up to this point, and now I made some changes. Am I as sure as about them as I was in the past time? Yes, I am. So I'm going to add it again. And notice now we only have one file, and it's because it's taken both those changes into account, adding the new sentence and adding the exclamation mark. So at this point, I've changed it, I've added it, I've changed it again, I've added it again. I can kind of keep leapfrogging back and forth until I'm sure I have something that I want, and I'm going to commit it. So I'm committing to the code. I'm saying I want this to work. The command is normally git commit m. You leave a message, and I'm like, this is for the project. Normally, it's a bit more descriptive. So the project I'm working on with Dr. Dory, one thing that I'm working on right now is a testing framework. So every time I create a new test, which might just be 3 lines, I run it, it's working. I break the code. The test says the code's not working anymore. So then I check the test that way, and then I commit it. And I just commit those 3 lines. And what's nice is that you can look through the history and see he wrote a test that checked that the user's logged in. He wrote a test that checked that the user's logged in, and he's an administrator. And the administrator page now displays these options as opposed to the non-administrator page, which doesn't display these options. So there's to be like 4 different commits, or it would be a bundle of commits saying like, this checks who's logging in and make sure they have the right privileges. So git commit, leave a message. This is for the project. Cool. Now if I do, and let me actually clear this because it's getting kind of messy. If I do git status, nothing to commit, working tree clean. So what that means is it has been committed. And at this stage, you would want to pull it into the master branch. And normally the way that's done is with GitHub. So Champ, do we want to actually pull something into our GitHub to show how that's done?
Sure. There is, I mean, you could use the ACM one, the one that's on the ACM GitHub organization.
Or I could do graphics. I have no idea what these things are, okay? But I want to show you what I'm doing. So what I'm going to do, and this is another useful thing about Git, is you can stash your changes. So are you familiar with the idea of a stack? Have you learned about that data structure yet?
Yes, definitely.
Cool. A git stash is a stack, and you add things to it, and then you can pop them off the top using the command git pop. So let's say you need to jump between branches. If I try to do that right now, error, your local changes to the following files will be overridden by the checkout. Please commit them, aborting. It basically says, hey, if you change from this branch back to your master right now, I'm going to delete all your work. So you don't want that. So one way to do that is to stash them. In other words, save those changes for later. But really what you're saving is the knowledge you've made these changes. So git stash git st. Untracked files, I actually don't need those files. So I'm just going to git add project file. What would be committed? Cool. And from here, I'm going to create a new branch that is git and then git stash apply adds all those changes, except when it doesn't. Cool. Yeah. So Git can be messy, and honestly, when that happens, you just look it up and it seems this worked. It says there was a conflict for modify and delete. Git add all, git commit. And since this is a real project, and my buddy Jonas might be looking at this, I'm going to say, Jonas, don't add. This is for an ACM demonstration. And that's helpful. That is helpful for somebody that might be reviewing your code before he merges it into master. So I've kind of talked about how you have master, it's all the working code. You have a branch where you can mess around with stuff, and then you can test it before putting it back on master. The real world application of that is it's never just you and your project. It's, well, that's not true, but more often than not, the farther along you get in computer science, it's not just you and your project, it's you working on a part of a project with 5 other people, and they each have their own branches, and everybody's code, it all needs to work together. And that's the really nice thing about having master and then having these individual branches, is you can then merge those branches in one at a time. And then there's actually a way in Git, and it's, I can keep going, but after somebody updates master, you can update your branch onto the new master to make sure that the changes they just made are compatible with your changes. And it really can start to look like a tree, not a pretty one, but one with all the branches kind of crisscrossed together. But what have we learned so far? We had a master, we made some changes, we liked them, so we committed them. And now what we're doing is we are going to ask them to be pulled into a repository. Now a repository is just, here we go, test branch has recent pushes, compare and pull request. So I've created this branch, and I want it to go onto not just my local master, I want it to go on the master for everything my project is doing in CS430 graphics right now. So I'm going to create a pull request. And what pull request is basically saying is, hey, I want you to merge this into master. So because what I just did is gibberish, I'm not going to. But that's kind of the final process. Once you hit this button, there's no going back. And that's kind of the power of Git is, well, there actually is going back. You can undo a pull request. It can just be kind of messy at times. The power of Git is it has all these layers, and they can be hard to master, but it starts with you creating a new branch. You have everything that's clean and happy over here, and you have your new branch here. You make some changes to it. You add them when you like them. You make some changes, you can add them. You make some changes, you add them. Once you review those changes, you commit them. And then you push them upstream to your repo with everybody, and you create a pull request, and you push them to a place where you ask people to pull it in. So you push, other people pull. That's the easiest way to think about it.
One real quick thing, Drew. I'm not sure, maybe you went over it. Did you talk at all about Git clone?
I haven't talked about creating a repo from GitHub yet. I just kind of talked about the basics.
Yeah. So if you have a repo on GitHub, or maybe you want to talk to somebody else's repo and play around with it, or repository and play around with it and see what their code does and stuff like that, command git space clone, and then you can provide it with a link or a repo, directory or anything like that, and it will create a local variant of it that you could play around with on your own machine.
So you have the idea of the master branch and branches going off of it. You have this one, which is the remote repo, which is what everybody's working on that's important. You can copy, paste that entire thing onto your own branch. So even if you screw up your local master, this one that we're looking at right here remains untouched. And if I hit merge request, it gets pulled in. As far as the file changes go, just because NAU is pretty strict about academic integrity, I don't want to show what changes I may or may not have not made to the raycaster. But one nice thing about GitHub is it actually shows you side-by-side file changes or line-by-line file changes. So it will say like, oh, line 4 used to not have a semicolon, it wasn't working. Luckily, Tyler found that, and now line 4 says the exact same thing, but with a semicolon. And it has green and red. Green is what's new, red is what's. So we created a branch off of master. We made some changes to it. We pushed them to GitHub, and now we can pull them in. So that way, everybody that's working on my raycaster can use those changes. But I'm actually going to close the pull request because I want to make sure nobody's pulling it in. And here's the comment: Jonas, don't add this. It's just a demonstration, and it's loading the file. So that's a perfect time to leave. So
and
as far, yeah.
Drew, Drew,
if you-
can't you set it up though? If you do the pull request, it doesn't immediately pull it in. It could put it into a state where it needs to be reviewed by whoever your code base organizer is before it actually gets pulled in, right?
And that is a feature with GitHub. And since you're new to this, GitHub and Git are actually two different things. GitHub uses the technology Git, and they sponsor Hacktober, which is using Git and trying to get people to learn how to use Git, which is why we're talking about it. But Git is kind of a generic technology. But what Dr. Dory said is actually really important. So just because that is a class project, which isn't the biggest project in the world, people can merge stuff in automatically. For my capstone and for the OLC, which is the project I'm working on with Dr. Dory, your code has to be reviewed before it can be pulled in. So that green button you saw where it said merge, that wouldn't appear. I can create a pull request, but it has to be merged by somebody else. And what that does is it forces you and another developer to collaborate over the code or review it before it gets pulled in and affects everybody then.
A little bit like peer review, seemingly.
Yes. It is to encourage peer review or make it impossible for your code, theoretically. Granted, if you're the tech lead and you really trust somebody, you could just say, oh yeah, I trust their work, merge without reviewing it, and then it wasn't good, and then you're both in trouble. But it is to encourage peer review, right? At the end of the day, you can't program human beings. If your boss says do peer review, do peer review. But it's not like it forces you to do it 100%. It just makes it so at least one other person has to theoretically look it over.
And on a real project in real life, there's usually there can easily be somebody on the team whose sole job it is to manage, review these pull requests and accept or reject them. That's like, the code base manager. And usually it is the tech lead, as Drew says.
And then here's another nice little visual demonstration. So right now I am in, scroll down. So you can see that I am in my 430 folder, which is right here. And specifically, it's the 430 folder within the 430 folder where everything is. And if I go to project 4, I can see I have some of the files we're working on. I actually just have a few because I'm in test branch. Let's say I want to go to master where all the good stuff is, git checkout master, or actually it would be project 4 because that's where everything is. Notice how all the files just changed, right? And that's, again, because this is what project 4's environment looks like. It has all these individual files. It has all these individual test images. So let's look at this. If I go back to project 3, it's kind of an easy question. Do you think project 4 is going to be there? In this case, it is, and it's actually because we had to copy paste the project 3 folder to create the project 4 one, but the actual project 4 code is not there yet. And we actually were kind of messing around, and this is another thing, it depends on how you set it up, but we were messing around with the code in project 3 and changing it there before importing it over to project 4. But that's kind of what I wanted to demonstrate. And then if I do if I go to project 2, it looks even different because this is the project 2 environment. And the git master environment, this is the really clean one. This is the one I care about. And I really care about this line. Your branch is up to date with origin/master. So that is sometimes it's the origin, sometimes it's remote. That's that one on GitHub that I was talking about. So remember the idea of cloning? I took everything that was on GitHub, that repo or repository, and put it on my machine. Well, if changes are made to that remote repo or repository, I want to make sure they can be reflected on my machine so that when I'm developing, I know that what I'm changing works with what everybody else changed. And when it says it's up to date with origin master, it is. And if you do git pull, do you remember how I talked about pull requests, the idea of pulling code from one place into another? You can issue the command git pull, which will actually pull any changes from the master. And And one thing I've never been able to figure out, and maybe somebody can help me, is why sometimes I get the status you are up to date and then I'm still able to pull things in.
Well, it said already up to date down there, Drew. So it does try to pull, but it then notes that it didn't pull anything.
Already up to date. Oh, thank you. I didn't see that. My bad.
Yeah.
Okay.
And the other thing to keep in mind is this is a really great way to, get involved with a lot of open source software projects. They're always looking for developers of like any skills to just add like, there's a lot of like, you could just add comments and document some code, read through code and document it. Or, any of these projects that people like are basically crowdsourced and don't have, full-time developers or anything like that. They're always looking for people, and there's many, many of them on GitHub. Like you can just kind of browse around and find stuff very easily. And then the other thing is, if you're not a command line person, I know like some people aren't, a lot of this stuff you can do just from the GitHub UI and that UI. You should try and learn it on command line, because it's honestly, once you learn it, you're like, this is so much faster and easier than doing it the other way, but it is possible still.
And there's also a lot of GUI clients for GitHub. Like I've used Source Tree in the past, and but I agree with you. You should definitely learn the command line version. And if you're heavy into the coding, that will be way faster than any GUI client.
Yeah.
Some IDEs actually integrated as well. I was talking about how recently I've been trying to make commits after I write an individual test for my project. And one of the reasons is I figured out the shortcut Command K. It adds and makes the commit automatically. It just asks you to make a message. And for a test, which may be 3 lines or which may be 50, being able to write that test and then commit it has been really, really nice. And then how often you make commits and how you format them can get kind of nitpicky. I mean, of course, people have come up with different standards online, as in what a commit message should look like. Some people have like kind of keywords at the beginning. It has to be one of 6 things because it falls into one of 6 different categories. It's either like feed for feature, like update for an updated feature, like test for testing. People can turn it into whatever they want. And the first time it was introduced to me, it was a little overwhelming, and I wasn't planning on giving this presentation until 15 minutes before ACM. So I'm sorry if a little bit of it was unclear, but hopefully I kind of illustrated the main idea, which is you have this nice clean area. It's the tree trunk of the branch, of the tree trunk of the tree with all the branches going off. That is master. You want to keep master clean. That is good practice. Do not merge something into master until you know it works. And if you really mess up your own local environment, it's great to have something in the cloud, AKA GitHub, that you can pull from. I don't know what he did, but somebody messed up their local environment for actually our 430 project. And he just goes, it's not that big of a deal. I'm just going to delete the folder and start fresh. I mean, think about how crazy that is. Like, I remember before I knew about Git, the idea of deleting a folder and starting an entire project fresh would scare me to death. But knowing that I can just say like git pull from this URL and then everything that I had is right there again makes development so much easier, and it keeps everything encapsulated. It doesn't matter if my code sucks and Colton's is great and we're working on the same thing, because, well, then Colton can add his good code and I can go back and change mine and then add it to Colton's code. So you're still combining the best of both worlds to get more efficient code. So the idea is you keep everything in different environments. Those environments are called branches. When you're sure that environment is nice and clean, you put it on the master branch. And the syntax of it will come with using it. Like, it's just kind of the way it goes. It's one of those things you can talk about, but until you actually start to use it in a development situation. For me, it wasn't until I got my job. Everything was just going over my head. And I was like, I kind of understand it, but when you use it, it becomes enlightening.
I think Nakai says it best, and he always says this: spend a day learning Git. It'll make your life so much better. You'll not know how you lived without it beforehand. You'll go, what was I doing before I knew this? But I think that's kind of a good wrap up there. I think we've kind of covered. Would you say so, Drew?
I hope so. Sorry, it was kind of a slow start. Any other things that you feel like I should hit on?
No, I felt like that was an excellent introduction for me. Anyway.
Cool.
Yeah. And it's just that, it's an intro. Like, if you expect to walk away right now with knowing all of Git, I don't think any of us even know all of Git. Like, maybe a lot of it, but it's not going to be something that you can just learn overnight. It'll take a while, and just play with it. Open up a repo and put a hello world program in there and see what happens. And then, do a little edit and then do something else.
And sometimes it will act up. Merge requests are where like I changed lines 1 through 10 and Tyler changes lines 1 through 10. And then it goes, you need to figure out which lines 1 through 10 you actually want. But it's never just lines 1 through 10. It's lines 1 through 10 and 212 through 213 and 1050 through 1200. Like, it blows up and it looks so ugly. And sometimes sometimes you want it all and it separates it automatically. Sometimes it just doesn't work. And when it doesn't work, it can be very, very frustrating. Recently in my job, there was a commit, and basically the commit said that we merged and committed something into something else. The commit was essentially just telling us that it was a commit. It was like this double layered commit. It was bizarre. It had to do with like us testing branches between machines and etc. So what did we do? Well, we made sure it was working and then pushed it, and then we still made sure it was working, and it ended up just being like this little blip on an otherwise very smooth branch, because that's the way it goes sometimes.
Yep. So thanks, Drew, for presenting. If you do have any questions, always feel free to put them in the Discord or, message any of us or ask them right now if you have them. But before we wrap up, here's some important dates coming up. So next week, we're doing kind of our de-stress epic fail night, where we're going to talk about how I think we've all failed at least once throughout this semester. I know I have. So I think that happens to everyone at least once. And I think it's good to talk about, just because to know like, hey, it happens to everyone. It happens to the best of us, no matter who you are and what you do. And then we're going to have a little bit of fun too. Maybe, do something a little bit lay back after midterms. I know it's been a stressful time for a lot of people. I heard for parallel, it was a tough exam for a lot of people. And then the week after that, we'll be off. And then we have State Farm coming on the 5th, and they're going to talk about some technical stuff. We're hoping machine learning, I think, but we're not sure yet. They're, it's up in the air until they get here, and then they'll tell us what they want to talk about. So that should be fun. There is a career fair going on tomorrow, and there's one going on today. So I think this is like your last chance to register for that if you, are interested in that. I know State Farm has said that they're reopening their intern application for till early November. So if you didn't get on that round the first time, hey, do it the second time. And then other things, we will have our elections at the end of this at middle of November. So if you're looking at running at a position, let us know. We gotta fill all the positions again, because we're all seniors. So all the officers are seniors and want to graduate.
Please run for an officer position. We want this club to stay alive.
I mean, short of this meeting, which is the midterms, it always dips. We've been having really good turnouts, especially for
Zoom
optional virtual meetings. Like, it's been great.
Yeah.
Mm-hmm. But yes, please message any of the officers if you're interested about our positions or what we do and what you can do to become elected or run for an officer position.
Yeah.
Hey, Tyler, who's coming from State Farm? Do you know?
We think Alex Kahn, but that's who we're contacting. Yeah.
Yeah.
Last
if
time
Alex doesn't contact me to have a beer, I'll be mad. You can just tell
him. Yeah, last time we had a whole bunch of State Farm people. They sent like 5 or 6 people, wasn't that right?
Yeah,
Cam?
there's 2 NAU alumni. There's Alex Kahn and Stephen White.
Yeah.
So.
Yeah, both of those guys were pretty top notch. So.
Yeah, so those are great things to look forward to. Thanks for coming out, and hopefully you learned a little bit about Git. Make sure you do Hacktoberfest, guys. It's really, honestly, a lot of fun. You get to learn a lot, and you get a free t-shirt or a tree, up to you.
Yeah. Do it for the environment. Plant a tree just
for
contribute to open source so you could plant a tree in the environment.
Just make sure the branches.
If you think about it, the environment really is the biggest open source project we have.
Thanks for coming out, everybody. Have a great night.
Yeah, thank you.
Bye-bye, guys.